This is my last bit of advice to work these problems. The reason that we're getting normal depth and critical depth is because we want to know what the default condition for a channel of that geometry is going to be. And that'll tell us what direction the control is coming from. So does the downstream conditions dictate what's going on upstream? And is that water moving faster or slower than the speed of a wave? And that will tell us if we got a mild slope or a steep slope. And so what you want to do is you want to start by figuring out the default condition, and then you want to see why the water is going to be at something other than normal depth, and then based on that decide what type of water surface profile you need to use. And so you would be well served to go back to that original vocabulary video to review first for the test, and then you want to have your book open, page 152, to review these water surface profiles. And that's going to tell us what's going to happen. So one example might be, we've got a steep slope going into a mild slope. And how do we know if it's a steep or mild slope? Well, if normal depth is supercritical, then it's a steep slope. And if normal depth is subcritical, then it's a mild slope. So in this case, we would have critical depth, and then it would be followed by drawing in normal depth. And if we wanted to try and draw our water surface profile, we could, we want to try and have an idea for what the water surface profile is going to look like before we do the calculations. And so if we have a steep slope, we're going to start upstream. And if we have a mild slope, we're going to start downstream. And those water surface profiles are going to stay at normal depth, working their way towards the control direction until it hits something. So the upstream water is going to stay at uniform depth until the change in slope, and then it would turn into an M3 curve to a hydraulic jump. And then that's going to jump right to normal depth, because if we go from downstream upstream, there's nothing that's happened until it gets to the hydraulic jump. But that's only one possibility. There's another possibility, which is that we start from downstream and we work our way upstream until there's a change, and that happens at the change in slope, and that would turn into an S1 curve followed by hydraulic jump directly to uniform depth. So these are the two possibilities for this particular example, and I went through an example like this. So what you want to do is you want to start by figuring out what is normal depth, what's critical depth, find out other places that we would know the depth, and then in your mind have an idea of what the shape of the water surface profile looks like, and start from a point that you know and work to a point that you want to find out using our energy balance methods or using our momentum balance methods. And so we used this figure in that vocabulary video to help us with that. One last thing, in terms of documenting your results, this is the answer to the homework, the first water surface profile homework that we did. There was water that was flowing in a mild slope. We've got an M1 curve, there's an M3 curve, hydraulic jump, and normal depth. And we defined this location as J, and this is our dimension for delta X. And so what I did is I just copied these cells and pasted the values over to the right of my spreadsheet so that I didn't have to go back and forth between the two. I should have done this in all the examples. So what we can do now is we can see, just looking at our spreadsheet, for example, what's the energy at normal depth, or what's the momentum at normal depth? And that momentum at normal depth is going to have the same momentum at the jump, or the energy at section B is going to have the same energy as the section I circled the wrong thing, at D. These two will have the same energy. So once you copy all the values that you know, then you can go back and you can say, okay, well, now I need to do the delta X calculation, and that's going to take place from B to J. So you can put those values in. Otherwise, on the test, I'm going to be expecting you to just tell me what the answer is, draw the water surface profile. If you want to document it, this is a good way to do it.